My name is Tricia Shannon, and I have a bachelor's degree of science in education from Western Illinois University. Currently, I teach 6th grade math at Northeast Community School District in Goose Lake, Iowa. Also, I serve as a model teacher on the Teacher Leadership Committee. The title of my paper is The Effects of Additional Math Instruction on High and Low Achieving Students in 6th grade. Today's world requires citizens to be able to problem solve and understand basic math in their everyday lives. There have been major changes in mathematical practices over the past decade that identify what is necessary for all students to learn in order to improve their mathematical ability. However, American students' math scores are still lagging globally. One of the tests used to assess the different countries is the Program for International Student Assessment, and the most recent results rank the United States 35th out of 64 countries in math. Also, the 2013 NAEP findings rate 36% of middle schoolers as proficient in math. I chose to do this research because I teach math students with varying math ability, and there's very little research on using the iReady program to improve overall math understanding and skills. The effects of additional teacher-led mathematics instruction has been researched in a variety of ways. Bottage, in 1999, found using teacher-led contextualized math instruction with small groups of middle school students had a greater impact on average and below average student ability to problem solve. Research that supports the idea of ability grouping to improve mathematical achievement was conducted by Vigdor. He also concluded that along with grouping students, an appropriate leveled curriculum needed to be implemented by the instructor. Vigdor blames the American math scores on not meeting students' different instructional needs. This conclusion was made from the Charlotte-Mecklenburg Algebra Initiative in 2001, which discredits the assumption of earlier completion of Algebra 1 had a direct effect on accomplishments later in life. The policy was based on the notion that students who take higher-leveled courses at a younger age are more inclined to achieve more. The students who were accelerated actually had poorer performance on the state's Algebra 1 test by approximately 13 percentile points. This indicates that instruction can't be equal or a one-size-fits-all model, but rather a system of differentiation. A different approach to the Charlotte-Mecklenburg Algebra Initiative is a double block of algebra offered to low-performing high school students at Chicago public schools. The additional block provides students more time for algebra support. Overall, the students who had 2 algebra classes had improved algebra grades and grade point average. Also, there is evidence to support double dosing algebra helps to improve junior ACT scores. Another study that shows positive results from implementing additional math interventions was conducted in 40 public middle schools from the Miami-Dade County. Curriculum-based assessments were given as a pretest and monthly thereafter to monitor problem-solving skill growth over the course of a school year. Not only did students who participate in the intervention show more growth than non-participating students, it had a large effect size of 0.882 on the performance of all students. But the intervention proved to be more effective for low-achieving students. Belfaz, Herzog, and McGyver conducted a study over the course of 8 years that focused on identification and intervention system for 6th grade students. The variables identified that had significant and independent predictive powers that 6th graders flagged would not graduate from the district on time or even 1 year later. These variables included attendance, failed math course, a failed English course, and suspensions. However, the findings showed course failings as one of the best predictors of not graduating. The research developed an intervention program around 5 concepts: predictive of student effort and achievement, which include teacher support, academic expectations, parent involvement, mathematical skill usefulness, and interest level. A major component of the intervention program is extra help labs that target weak math skills. Evaluations of the intervention program have shown significant improvement on student achievement. Middle school students in the program had a 6% course failure rate in math compared to the 15% of non-program students. My research question is, what effect does 30 minutes of additional math instruction have on low and high achieving students? The purpose of this study is to determine if low or high achieving students learn more effectively in small groups with teacher-led instruction using the iReady curriculum to track and monitor mathematical growth. As the practitioner, the findings will affect mathematical instructional strategies used to improve student growth in my own classroom. Research has shown the positive effects of ability grouping along with appropriately leveled curriculum on mathematical achievement in middle school. However, there was little research about what type of instruction was used in these groups. The research design for this study is a single studied baseline design. This study will not include a stability criterion, but rather a fixed time period for the phases. A baseline will be established using their iReady diagnostic math test score for all participants. Participants were assigned to high and low achieving student groups based on their results. This design was chosen to measure growth over time. The participants were 6th grade boys and girls ages 11 to 12 years old that were enrolled in general education math. The sample consisted of 6 males and 4 females, all Caucasian. The 5 highest scoring and the 5 lowest scoring students were recruited to be part of the study at the school using their iReady results. The 10 participants were split into 2 groups, high achieving and low achieving. The materials used to measure math growth were the iReady Math Diagnostic Test and the Growth Monitoring Assessment. Both iReady tests were adaptive assessments, meaning the test provided easier or harder questions based on the student's response on previous questions. The Growth Monitoring Assessment is considered a shorter version of the diagnostic test and takes approximately 15 minutes to complete. Both tests use the same scoring scale to help track student growth over time. This test provides criterion-referenced scores to describe a student's performance. Scores are expressed using scale scores and placement levels. Scale scores allow for comparison across grade level and are a measure of showing skills mastered up to a certain point. Students are also classified using placement levels early, mid, or late to determine what types of skills students should be receiving. The devices in this study had Google Chrome installed due to the iReady being only accessible on the internet, and participants were using an HP laptop computer that was compatible with the iReady program. The repetition of phases ensured the reliability of these findings. And to ensure the internal validity, students were not made aware of the hypothesis while participating in the study. And to ensure external validity, instruction was in the same classroom and time frame each day for both groups. Furthermore, the participants were a representative sample of the 6th grade population at Northeast. Using a paired sample t-test, the remedial and enrichment group on the diagnostic test was compared to determine whether the mean difference between the 2 related groups was statistically significantly different to 0. The growth from the first diagnostic test to the last diagnostic test was analyzed to conclude whether the extra 30 minutes of daily math instruction had a significant effect on the remedial or enrichment groups. This information was used to determine the continued use of iReady as a math intervention program in the classroom. My prediction was that low-achieving students who were provided an additional 30 minutes of teacher-led math instruction based on their mathematical areas of need would have greater gains than high-achieving students on the iReady Math Diagnostic Test. Using diagnostic test results before and after the remedial or enrichment instruction, there was no significant difference in the growth for the remedial group or enrichment group. These findings fail to reject the null hypothesis. In fact, the high-achieving group showed more growth than the low-achieving students. This is not supported by much of the research discussed in the review of literature section. This raises big questions of why and what can be done to improve low-achieving student growth. A limitation to this study is a larger sample size, and that would yield more accurate results. Therefore, the 10 participants in the study would pose a threat to internal validity. To determine the recommended sample size for the study, a confidence level of 95% along with the margin of error in populations establishes that a larger sample of 29 participants would yield more accurate results. With a larger sample size, it would provide more accurate data that could increase the ability to generalize the findings. This could be possible if there were additional teachers available or the block of time was longer. Another component of the sample size limitation that could hinder internal and external validity is the overall size of the subject population and diversity of the participants. First of all, there are only 53 sixth grade students in the school population, with all students being Caucasian. The participants are not representative of all sixth grade students across the state due to the lack of ethnic diversity within our school population. In this study, iReady is the only measure used to assess student mathematical growth. Many studies use multiple measures to improve validity to get an overall indication of growth. By only using one measure, this could limit the validity of the study. Another measure the research could implement is Academic Improvement Measurement System based on the web, which is also referred to as Ames Web. And that could be used as a progress monitoring assessment. By implementing another study measure, the external and internal validity would greatly increase. The implications of these findings have a direct effect on students. The researcher predicted that the iReady lessons would greatly benefit both low and high achieving students, but have greater effects on the lower group. Most students have weak areas in math. With the adaptive testing ability, iReady would benefit all students by identifying the areas of need in math and design lessons to strengthen the skills in those areas. This is a powerful tool in a classroom with a varying degree of mathematical ability, like many general education classrooms, and especially those that include special ed students. This study also has a great impact on teachers by taking out the time-consuming task of identifying gaps in student learning and providing engaging lessons to quickly bring students up to grade level in all areas of math. Teachers can perform their educational duties more effectively and efficiently, resulting in more student learning. If the iReady program increases diagnostic math scores, then it has the potential also to increase standardized test scores. This could have a profound effect on teachers and school districts. Here are my references I used in my paper and presentation. Thank you.